The term dark matter is effectively used to refer to anything about the genome that we don't understand. So these are the pieces of DNA that sit in between genes or in between the protein coding regions of genes. Some of those pieces certainly have a function, but we don't really understand yet what all those functions are. And so they're often referred to collectively as this dark matter of the genome. A huge amount of what we talk about in science is about good storytelling. So as part of that storytelling, a powerful analogy can be a really important thing. It's a good way of getting a message across and communicating a complex topic in a way that people can understand. As soon as you hear the term dark matter, you understand immediately this is a substance that is mysterious, that we don't understand in some way. But at the same time, it doesn't really carry any information. It doesn't tell us what we don't understand or exactly what it is that's interesting about the things we're trying to communicate. One of the things that people think about when they hear the term dark matter is something that can't be seen. And in fact, of course, that's not the case for the non-coding regions of our genome. We know that they're there, and in fact, we can read their sequence precisely. We don't know what they do, and that's actually quite different from the dark matter in a physics sense, which is a type of matter that we can't actually see. Another problem that I think comes up with the term dark matter is that it conveys that it will actually be extremely difficult for us to really unravel and understand in any meaningful way. But in fact, we're already starting to make progress. We have a map of all of the regions of the non-coding genome where we think it's likely that there are functional regions. It's actually extremely difficult to come up with a better way of communicating this complex topic to a wider audience. And it's certainly much better than previous analogies for the same non-coding DNA, such as, for instance, junk DNA. The term junk DNA really implied that for everything, every piece of the genome that didn't code for a protein, it had no purpose, it didn't actually do anything at all. We now know that there is actually a reasonable proportion of that so-called junk DNA that does have a function. So in many ways, at least, it is an advance over the types of analogies that we've used previously for the same concept.